In this video, we shall review the March 2021 KCSE paper 1, section 1, starting from question 1. Without using mathematical tables or a calculator, evaluate -3 into 6 plus -2 minus -12 divided by 4 plus 5 divided by -4 times -6 plus -3 times 5. So we are supposed to evaluate without using mathematical tables or a calculator. And to do that, if that is our expression, we are going to use the order of operations, which is whose acronym is BODMAS, that is brackets of division, multiplication, addition, and subtraction. And we are going to start with the numerator. We have -3 into 6 plus -2 minus -12 divided by 4 plus 5. So we start by evaluating the brackets. We have 6 plus -2. This can be rewritten as 6 minus 2, and 6 minus 2 is 4. Therefore, we have -3 times 4 minus -2 divided by 4 plus 5. The next operation is the division. We have -12 divided by 4, so that becomes -3, and therefore we have -3 times 4 minus -3 plus 5. Then multiplication, -3 times 4 is -12. So we have -12 minus -3 plus 5. Then we simplify -12 minus -3 plus 5. The negative and the negative before 3 can be expressed as a positive, because a negative times a negative is a positive number. So we have -12 plus 3 plus 5. We simplify that, it becomes -12 plus 8, and -12 plus 8 is -4. Then we evaluate the denominator. We have -4 times -6 plus -3 times 5. The first operation is multiplication. So -4 times -6 is -24, and -4 times -6 becomes +24, and -3 times 5 becomes -15. So we have 24 plus -15. We can simplify this as 24 minus 15, because a plus followed by a negative can be simplified as a negative. A plus and a negative is a negative, but a negative and a negative forms a positive. So we have 24 minus 15 is 9. So our expression evaluates to -4/9. Question 2. Express 5.5 recurring as a mixed number. So the 5 after the decimal is the recurring number. We are supposed to express it as a mixed number. So the first step is we shall let our given expression to be x. So x is 5.555 because 5 is recurring. Then we need to eliminate the recurring part, and since the recurring is to 1 decimal place, we shall multiply both sides by 10. So that means 10x is equals to 10 into 5.555. So we have 10x is equals to 55.555. Then we subtract the x from the 10x to eliminate the recurring part. That means 9x is equals to 50. We divide both sides by 9 to find the value of x. So x is 50/9, but we have been told to express the answer as a mixed number. So 9 goes to 55 times and there's a remainder of 5, so x is 5 over 9. Question 3. Without using a calculator or mathematical tables, evaluate 49 raised to power 3 over 2 times 256 over 2401 raised to power 3 over 4. So we need to evaluate this without a calculator or mathematical tables. The first step is to factorize the whole numbers, and we start by 49. The smallest divisor of 49 is 7. And if you divide 49 by 7, you obtain 7. The smallest divisor of 7 is 7. And so 49 is equals to 7 times 7, which in power form can be written as 7 raised to power 2. Then we factorize 256. The smallest divisor is 2. We obtain 128 divided by 2, 64, divided by 2, 32, divided by 2, 16, divided by 2, 8, by 2, 4, by 2, 2, and by 2, 1. Therefore, 256 is 2 raised to power 8. Then finally we have 2401. The smallest divisor is 7. We obtain 343, divided by 7, it's 49, divide by 7, 7, and divide by 7, 1. So 2401 is 7 raised to power 4 in its power form. So therefore, 49 3 over 2 times 256 over 2401 raised to 3 over 4 is the same as 7 raised to power 2 raised to 3 over 2 times 2 raised to power 8 over 7 raised to power 4, the whole of it raised to power 3 over 4. We open the brackets by multiplying the powers, and we obtain 7 raised to power 3 times 2 raised to power 6 over 7 raised to power 3. The 7 raised to power 3 cancels out, the 1 in the numerator and the denominator, and we are left with 2 raised to power 6. We rewrite it back as a whole number, that is 64. Question 4. A rectangular floor measures 5.4 meters long and 4.2 meters wide. The room is to be covered with square tiles. Calculate the minimum number of square tiles that can be used to cover the floor. So you've been given the dimensions of the room, and you need to find the minimum number of square tiles that can be used to cover the room. Assuming that is the floor, we have the dimensions of 5.4 meters by 4.2 meters and a sample square tile with dimensions x and x. We need to find the minimum number of the blue tiles. So for us to obtain the minimum number of tiles, x must be maximum possible. And that means we need to find the highest common factor in the floor dimensions, that is the HCF or the GCD. So the first step is to convert the dimensions of the floor into centimeters, which makes it easier to compute. So the floor dimensions in centimeters are 540 and 420. Then we find the HCF of the two. The smallest divisor of 540 and 420 is 2. You obtain 270 and 210. Then divide by 2. We have 135 and 105. Divide by 3. 45 and 35. Divide by 5. You obtain 9 and 7. We don't have a common factor between 9 and 7. So that implies that our HCF is 2 times 2 times 3 times 5, which is equals to 60. And so this means that the value of x, or the tile dimension, is 60 by 60 centimeters. So now that we have already obtained the dimensions of the tile, we need to find how many tiles will fit in that floor. And to do that, we need to find the area of the floor, then divide it by the area of each tile. The area of the floor is length times width, which is 540 by 420. we obtain 226,800 square centimeters, and the area of each tile is 60 by 60, which makes it 3,600 square centimeters. So the number of tiles is 22,600 over 3,600, which is equals to 63 tiles. So that is the minimum number of square tiles that can fit in that floor. Question 5. Simplify 2x squared minus xy minus 6y squared over x squared minus 4xy plus 4y squared. So to simplify this expression, we need to factorize, and assuming we have a general expression ax squared plus bxy plus cy squared, to factorize, you need to find the factor pairs whose product is equals to a times c, and the sum is equals to b. So starting with the numerator, we have 2x squared minus xy minus 6y squared. The a is 2, b is -1, c is -6, and ac, the product of a and c, is equals to -12. So we need to find the factor pairs of -12, and they are -112, -26, -34, -43, -62, and -12,1. So out of these factor pairs, the pair whose sum is equals to b, or -1, is -43. And so we are going to use these factor pairs to expand our second term xy, and that gives us 2x minus 4xy plus 3xy minus 6y squared. Then we group the terms and find the like terms in the groups. In the first set, we have 2x is common in 2x squared minus 4x squared. So we have 2x into x minus 2y, and 3y is common in 3xy minus and -6y squared. So we have plus 3y into x minus 2y. Then we group them. We have 2x plus 3y into x minus 2y. Then we do the same for the denominator. We identify the coefficients. We have a is 1, b is -4, c is 4, and so the product of ac is 4. Then the factors of ac, we have -1, -4, -2, -2, 1, 4, and 2, 2. And the factor pair whose sum is -4 is -2, 2. We expand our expression. We have x squared minus 4xy plus 4y squared is equals to x squared minus 2xy minus 2xy plus 4y squared. So we group the terms and pair them. We have x into x minus 2y minus 2y into x minus 2y. In simpler expression, it can be written as x minus 2y into x minus 2y. So we combine and we go back to our expression. We have 2x squared minus xy minus 6y squared over x squared minus 4xy plus 4y squared is equals to the factorized expressions. Then we simplify and we obtain it's equals to 2x plus 3y over x minus 2y. Question 6. The line 2y plus x is equals to 1 is perpendicular to a line L. Line L passes through point 2, -1. Determine the equation of L in the form y is equals to mx plus c, where m and c are constants. We've been told that line 2y plus x is equals to 1 is perpendicular to line L, and L passes through the point 2 and negative 1. So for perpendicular lines, the product of their gradients is equals to negative 1. Then we shall let the gradient of line 2y plus x is equals to 1 be m1, and for line L be m2. Then for line 2y plus x is equals to 1, we need to find its gradient by rearranging it to the form y is equals to mx plus c. So we eliminate the x by subtracting it on both sides of the equation. We have 2y is equals to negative x plus 1. Then divide both sides by 2. We obtain y is equals to negative a half x plus a half. So that means the value of m1 is equals to negative a half. And then since the product of their gradients is negative 1, it means m1 times m2 is equals to negative 1. We substitute the value of m1, then we multiply both sides of the equation by the reciprocal of negative a half to obtain the value of m2. And so our m2 is equals to 2. Then using the point that we have been given for line L, that is 2, negative 1, and the equation of the line form y is equals to mx plus c, we can substitute the values of y, m and x to find the value of c. So negative 1, which is the value of y using the point 2, negative 1, is equals to 2 into 2 plus c. So negative 1 is equals to 4 plus c. We can write it as c plus 4 is equals to negative 1. Subtract both sides. Subtract negative 4 from both sides of the equation. We obtain c is equals to negative 5. So the equation of the line is therefore y is equals to 2x minus 5. Question 7. The sum of the interior angles of a regular polygon is 1260 degrees. Find the size of each exterior angle of the polygon. For illustration purposes, we have an example of a regular polygon, and the yellow shaded angles are the interior angles, the green shaded angles are the exterior angles. We have been told that the sum of the interior angles is equals to 1260 degrees, and we need to find the size of each exterior angle. So letting the number of sides be n, using the principle of triangles, the sum of the interior angles is equals to 180 degrees into n minus 2. So we substitute that. We have 1260 degrees is equals to 180 degrees into n minus 2. Divide both sides by 180. We have 7 is equals to n minus 2. We can rewrite this as n minus 2 is equals to 7. Add 2 on both sides of the equation, and therefore n, which is the number of sides, is equals to 9. Then for every polygon, the sum of the exterior angles add up to 360 degrees. And so each exterior angle is the sum of the exterior angles divided by the number of sides. We substitute, we have 360 degrees over 9. So each exterior angle in the example that we have been given is 40 degrees. The equations are x minus 4y is equals to negative 5 and negative x plus 2y is equals to 1. So the first step is to find some points to plot the two lines. We have x minus 4y is equals to 5. So we need to find the values of x and y. When x is -1, y is 1. When x is 3, y is 2. And when x is 7, y is 3. Then we have -x plus 2y is equals to 1. Find the values of x and y. When x is 1, y is 1. When x is 3, y is 2. And when x is 5, y is 3. So we plot these points. That is the x-axis, and the y-axis. 0, 1, 2, 3, 4, 5, 6, 7, and -1. We have 1, 2, 3, 4, 5, 6, 7, -1. So we plot -1, 1. We have 3, 2, and 7, 3. Join the points. This is the line x minus 4y is equals to 5. Then we plot 1, 1. 3, 2, and 5, 3. This is the line -x plus 2y is equals to 1. Then the solution is where the lines intersect. So we read off the values. X is equals to 3. And y is equals to 2. So these are the solutions of the simultaneous equations. Question 9. Given that sine theta plus 30 degrees is equals to cos 2 theta, find the value of cos theta plus 40 degrees. We have been told that sine theta plus 30 degrees is equals to cos 2 theta. Find cos theta plus 40 degrees. To illustrate, if we have a right angle, one of the acute angles will be x and the other will be 90 minus x. So, for a right angled triangle, the sine of any acute angle is equal to the cosine of its complement. That means, using our example, sine x is equal to cos 90 minus x. And the cosine of any acute angle is equal to the sine of its complement. So, cos x is equals to sine 90 minus x. So using the expression we've been given, sine theta plus 30 degrees is equals to cos 2 theta. Assuming theta plus 30 degrees is our x, so sine theta plus 30 degrees will be cos 90 degrees minus theta plus 30 degrees. And so we can equate the cos 90 minus theta plus 30 degrees to cos 2 theta. Then since they are both cos, we can factor out the variables. We have 90 minus theta plus 30 degrees is equals to 2 theta. We open the brackets, we have 90 degrees minus theta minus 30 is equals to 2 theta. We put the like terms together. We have 60 minus theta is equals to 2 theta. Add theta to both sides. We have 60 degrees is equals to 3 theta, which can be written as 3 theta is equals to 60 degrees. Divide both sides by 3 and we obtain the value of theta as 20 degrees. So we are supposed to find the value of cos theta plus 40 degrees, which is cos 20 degrees plus 40, or cos 60 degrees. You can evaluate this using your calculator and you obtain the value as 0.5. Question 11. Using a ruler and a pair of compasses only, construct a parallelogram ABCD in which AB is equals to 6 centimeters, BC is equals to 5 centimeters, and angle ADC is equals to 150 degrees. We are required to construct a parallelogram ABCD, in which AB is 6 centimeters, BC is 5 centimeters, and angle ADC is 150 degrees. So we start off with a rough sketch. In a parallelogram, opposite sides are parallel. So this side is parallel to that, and this one is parallel to this. And our ADC is 150 degrees. Since this is the obtuse angle, we shall label this as 150 degrees. That means this is D, this is our A, this is C, so this becomes B. And AB is 6 centimeters, BC is 5 centimeters. Since DC and AB are parallel, it means angle ADC and DAB are supplementary. That is, they add up to 180. So DAB will be 180 minus 150. So this becomes 30 degrees. So we shall construct angle 30 degrees at point A. We start off by drawing a line and we mark this as our point A. We need to measure 6 centimeters to obtain point B. That is our point B. This is 6 centimeters. So to construct 30 degrees, we need to start by constructing 60 degrees and then bisect that angle. So have your compass at any radius and make an arc that cuts across the solid line. Then move your compass to the point to where the arc intersects with the line, and using the same radius you make another arc. Then since this is 60 degrees, we are only going to make it a dotted line since our angle of interest is 30 degrees. So you can change the radius and you mark on both sides. Then adjust the radius again. So where these two arcs intersect, that is our angle 30 degrees. So we make this a solid line. Then BC is 5 centimeters. That means AD is 5 centimeters as well. So this becomes our D. And BC is 5 centimeters. So we make an arc where the 5 centimeter lie. Then DC is equal to AB, so that is 6 centimeters as well. So we measure 6 centimeters. From point D. And so that means this is our point C. So we join to form the parallelogram. There you have it. Question 14. A vertical electric pole was erected 6.4 meters from the foot of a vertical fencing pole on the same horizontal level. The fencing pole is 2 meters high. The angle of elevation of the top of the electric pole from the top of the fencing pole is 30 degrees. Determine the height of the electric pole correct to one decimal place. So using an illustration, we have the electric pole and the fencing pole. The distance between them is 6.4 meters and the angle of elevation from the top of the fencing pole to the top of the electric pole is 30 degrees. So we need to find the height of the electric pole, and we are going to start by obtaining the height of the electric pole that is higher than the fencing pole. And to do that, we are going to use trigonometric identities. In relation to the angle of elevation, we have the adjacent, which is the same as the horizontal distance between the two poles. Then we need to find the value of x. So we are going to use tan. So tan 30 degrees is equals to x over 6.4. We cross multiply, it means x is equals to 6.4 tan 30 degrees. You compute this, you obtain the value of x is 3.6950. So the height of the electric pole will be x plus the height of the fencing pole. Substitute, we have 3.6950 plus 2, which is 5.6950, and we are supposed to give the answer to one decimal place. That becomes approximately 5.7 meters. Question 15. In our 4x400 meters relay competition, a team of athletes each completed their round in 45 seconds, 43 seconds, 44 seconds, and 45 seconds respectively. If the race started at 1:35:31 p.m., find the time when the team completed the race. So the first thing is to find the total time taken by the team. So we add up the times that were taken by each member, and the total time is 177 seconds. Then we convert the seconds into minutes and seconds. Divide by 60, we have 2 minutes and 57 seconds. Then the race started at 1:35:31 p.m. So we add the 2 minutes and 57 seconds into it. And we obtain 1:38:28. So the completion time was 1:38:28 p.m. Question 16. The figure below shows a quadrilateral ABCD and a mirror line M1, M2. Part A. Draw quadrilateral A prime, B prime, C prime, D prime, the image of ABCD, and a reflection in the mirror line M1, M2. To perform the reflection, we are going to measure from the point to the mirror line at a right angle. So we're just going to plot straight lines to the mirror line, but it has to be at a right angle to the mirror line. And we'll have them dotted. Then you measure from point C to the mirror line. In our case, it's 3.6. So we mark on the dotted line. That is point C prime. We do the same for all the other points. This is 4.9. That is point D prime. .5. That is B prime. And 3.6. That is A prime. Then now you join the points that you have marked. And there you have your reflection. Part B, set the type of congruency between A, B, C, D and A prime, B prime, C prime, D prime. So from part A, that is what we did. Then from this image, we can tell that A prime, B prime, C prime, D prime has been laterally inverted. So that means A prime, B prime, C prime, D prime is oppositely congruent or indirectly congruent.